Welcome to another tutorial. In our previous tutorials, we've learned how to scan the four groups of tokens that make up our language sentence. In this lesson, we'll learn how the make token and generate token function generates the scanned tokens. The make token function is the main function that generates our tokens. The generate token function is used to process tokens which store data before finally calling the make token functions. There are 5 tokens that store data. They include token number which store integer values, token identifier which store identifier name, token function which store name of function, token function call which store the name of called functions, and token string which store string values. Other tokens do not store values, example token plus, token comma, and the rest of the tokens. The generate token will process the data and attach it to the token before calling the make token function. So we first declare a global token type called previous token. We are going to use this to store the previous token sent to the make token. We are going to use it later. We also define our generate token function right above the check keyword function and before the make token function. It takes only one argument, which is the token type whose data we would like to generate. Next, we create an empty string called token data, which will store the data we want to attach to the token. Then we use 4 if conditions for number 1, token number, token infinite, token string, and token identifier. Token fun and token function call are all under the token identifier, since function names are user-defined names. Then, to generate data for token number, we use a while loop. While it is not end of file and while the current token is a number, we concatenate to it the token data and increment our token to point to the next character in our data until we get a token that is not a number, maybe a white space, or if we get to the end of the file. Then we'll push the pointer back because the scanner will still increment it to the next token. Here. Next, we check if we are at the end of file. If we are at the end of file, it means that the end of file terminated the loop. Then we throw an error because the number was not terminated properly. Else we call make token to make token number using the token data and the token type. The make token function is implemented using polymorphism, so we can call it without a token data for the case of tokens that do not store data. Next, the token infinite. This token refers to double semicolon. In C++, they are used for infinite loop. Also, using the single value 1 in a while loop also denotes an infinite loop. So we can simply replace it with token number whose value is equal to 1 since they are similar. So this is because the equivalent and is easier to work with numbers than with symbols, as we are going to see later. Then next is token string. Remember that in C++, strings are terminated with double closing quotes. So for token string, we are going to loop until we meet the end of file or we meet the double quotes. So we keep concatenating the token data and shifting to the next token until whenever the loop breaks, we check if the current token at that point is a double quote or end of file. Then we generate token string with the token data. Else it means that the end of file terminated the string, therefore we throw an error. Finally, the token identifier. Identifiers consist of only numbers, alphabets, and an underscore. So we are going to loop so long as the token is either of these 3 acceptable tokens. We break the token if the current token is neither an alphabet, nor a number, nor an underscore. Then we slide back one step as explained earlier. Then we check if we are at the end of file. We also throw an unterminated identifier error if the string was not terminated. That is, if we got to the end of file without seeing a double quote to terminate the string. In C++, any identifier that is preceded by an opening brace is either a function call or a function declaration. So if the next token after our identifier is an opening brace, then the identifier is either a function call or a function declaration. Now this is where we are going to use the previous token crowbar variable which we declared earlier. So we would like to differentiate between a function call token, also known as a token fun call, and a function declaration and initialization token, also called token fun. And the major difference between the two is that function calls do not have a function type associated to them, while a function declaration or initialization must have a function type associated to them. Example, when you write void scanner is a function declaration because it has the type void attached to it, or int scanner, it has a type of integer associated to it. But when you write only scanner followed by an opening parenthesis, it's assumed to be a function call. So at this point, if the current token is a function declaration, it means that we've already sent the function type to the make token function. So we check the last generated token in the make token function, and this token is referred to as the previous token. So we compare it with the standard function types we have. Our standard function types for our language includes token var for integers, token void, token string for string functions, token bool, and token pin. If the previous token matches any of them, then it's definitely a function declaration and not a function call. So we call make token to generate token fun. Else, if it does not match any token type, then it's a function call. Finally, if the identifier is not preceded by an opening parenthesis, it means that it's neither a function call nor a function declaration. Therefore, it's just an ordinary identifier. So we make token for token identifier. In our next tutorial, we will define the make token to finally output our token to a file.